bomb calorimetry problem. Okay, so bomb calorimetry, just kind of let you know what's going on here. They have a thing that looks like this. I'm putting a little lip in it. It's actually a container filled with water. It's got water in it. It's got something that can measure this thing with temperature. And in the center of this thing, there is a little vessel they have. And it has a sparker in it. And they blow something up in it. And then they measure the heat change, delta T, that's going to occur in the water. It's supposed to be H2O here. It looks kind of sloppy. But it's a bomb calorimeter. Okay, so the math for doing this is a little different than the coffee cup calorimeter, but this one actually works fairly well. It's an expensive unit to have to do it, but that's okay. We're just going to do the problems on it. So the first thing it says 1.8 gram sample of phenol, right, was burned in a bomb calorimeter. Whose total heat capacity is 11.66 kilojoules degrees Celsius, right? The temperature of the calorimeter plus contents increased from 21.36 to 26.37. A, write a balanced chemical equation for the bomb calorimeter reaction. We can do that, right? C6H5OH, and we're going to blow this up with O2, right? So I'm going to add it with some O2. It's going to yield, we did this thing right, OCO2 plus H2O, because it's a combustion reaction. We go back and forth on this thing. I guess the easiest thing is just kind of like look at this. This would be a, oh, we got 6. 3 of these. 1, 2, 3. Oh, we got an extra one here. That's going to work. Put a 6 in front of him. I got 6. I got 12, 13, 14, 15 O's. 1. Put a 7 in front of this. Oh, all right. It's easy. All right. Now, let's get our stuff for this thing. What is the heat of the combustion per gram of phenol per mole of phenol? Right. So we're going to do the first one, then we'll do the second one. First, we'll note the temperature change. We're going to go from 26.37 degrees Celsius and go to 21.36 degrees Celsius. All right. So this right here would end up being equal to 5.10 degrees. 5.01 degrees Celsius equals my temperature change. Nice. Okay, that's good for us, right? Now, we get this number, and we got to use it. So for every 5.01 degrees Celsius that we change, we just multiply it. Look at the units to get rid of this. You multiply this number by 11.66 kilojoules per degree Celsius. How it's set up is they know how much water in there, how much everything's going on. So every time you blow this thing up, you know, for every degree you go up, you change that many kilojoules. So what happens is this is going to cross out and this is going to cross out. And then you just simply multiply across. You end up with 58.4 kilojoules total is the amount of energy, all right, so far. But it says, what is the heat of combustion per gram of phenol, right? So it's kind of simple at this point, right? You take this number, because it's blown up, right? Heat's being released as a combustion reaction. It's always going to be negative, so it's exothermic. It's exo. I take the number 58. Oh, sorry, I don't want that dot there because that's going to look messed up. 58.4, right? And I'm just going to simply divide it by 1.800 grams, because that's mentioned up here, okay? And when that happens, it's going to tell me how many joules per gram, right? Kilojoules per gram. And remember, this is kilojoules. So is it being minus 32.5 kilojoules per gram of phenol, which is C6H5OH, right? Minus 32.5. Nice. But it's saying how much of this, now they want to know what's it per mole. Okay, we got to do subsequent calculation, right? How we do that is that we're just going to take this number and roll with it. It's 32, okay? So I'm going to move it over here. So I'm going to erase some of this here. So I got room to do this. Okay, I take this out. Here we go. Take you back down to 4. So if I have minus 32.5 kilojoules per gram of phenol, right? I'm going to just write phenol, right? And well, how many grams do I have per mole? So I know the formula weight of phenol, I know is equal to 94.11 grams of phenol equals 1 mole of phenol. All right. And then you just multiply across, you're going to get a huge number probably, right? And you get negative 3.054 times 10 to the 3 kilojoules per mole of phenol, which is C6H5OH, right? So it says this, but it really, I mean, it's a huge number, 3054 negative, right? Kilojoules per mole. But I just wrote it like this because it looks better. That's how you do bomb calorimeter. Right? So you find out what the joules is, kilojoules per degree raised, and you kind of work it out. It's kind of a little easier because you don't have the water element, but that's how you do it.